Our final lesson in topic 0 is 0.5. We're continuing with linear equations. In this lesson, we'll write equations and graph them for parallel and perpendicular lines. Let's first start with parallel lines. Parallel lines are lines that have the same slope. And because of that, they never intersect. Let's take a look at the example on the right. Write an equation in slope-intercept form of the line that passes through -8, -6, and is parallel to y equals -5x plus 5. Then, graph the two lines to check. Well, this looks like there's a little bit of a typo there. Sorry, you guys. We'll put the comma there, make that a lowercase. That's better. All right, so let's take a look at our original function. Y equals -5x plus 5. The slope would be -5. A parallel slope is the same. So we'll write that down. The point we want to go through is -8, -6. That's going to be like our x1 and our y1. So let's identify that. Once you know your slope and your y-intercept, we'll use the template from day 1. Y minus y1 equals m times x minus x1. Substituting in what we know, we have a lot of negatives happening here, and we actually end up with a pretty crazy y-intercept. So y minus y1 is -6. Our slope is -5. And then x minus x1, which is -8. With all these negatives, we actually get a double negative to cancel out a couple of times, with the y and with the x, leaving us with y plus 6 on the left. If we distribute the -5 in, -5x minus 40 on the right. To get y by itself, I'm going to move 6 to the other side, and we end up with y equals -5x, minus 46. That's a crazy y-intercept to graph. It says graph the two lines to check. Let's graph the first one, y equals -5x plus 5, and then we'll talk about how to graph the second one. The graph for y equals -5x plus 5 is a very steep line that crosses the y-axis at 5. I then counted down 5 and over 1, down 5 over 1 again, until I got to the edge of the graph. Now when we're trying to graph the second line parallel to it, our y-intercept is -46. That's not feasible to graph on this coordinate system. So what I'm going to do first is I'm going to plot the point that they gave us in the directions. -8, -6. I'll count over to -8, down to -6. That should put us right here. Now, if my slope is -5, that means I count down 5, and I go off the graph, and I'll go 1 to the right. So I have to kind of approximate that. However, I can go up 5, 1, 2, 3, 4, 5, and 1 to the left. And you can go up 5 more, 3, 4, 5, and 1 more to the left. That gives you a few points to plot. Go ahead and connect these dots. While they're not exactly straight, because my pen isn't working very well for me again, they do appear to be parallel. Moving on to parallel lines. Parallel lines are lines that intersect to form a right angle. That's a T. There we go. To form a right angle. With perpendicular lines, the thing to remember with slope, we'll say slopes are, there are two things unique with perpendicular lines. The slopes have to have opposite signs, meaning one has to be positive and one has to be negative. And the slopes are reciprocals of each other. Those are the two rules or the two criteria to be perpendicular. In our second example, It says write an equation of a line perpendicular to y equals negative 5/6 x plus 4/3 that passes through the point negative 1, 3. Very similar in nature to the first example, only now we're going to have to convert our slope. In this original equation, our slope is 5/6. To make that a perpendicular slope, my perpendicular symbol is going to be an upside down T with kind of a box in the corner. What we're going to do is change the sign to negative and flip the fraction. So it's going to be negative 6 over 5. The point we want is negative 1, 3, and that's our x1 and our y1 again. Now, just like last time, once you know your point and your slope, the rest is just kind of plugging it into that formula and simplifying. Y minus y1 equals mx minus x1. Substituting in what you know, y1 is positive 3. The slope is negative 6/5. This might get a little messy with those fractions. And then x1 is negative 1. So now we have a double negative as well. Go ahead and clean this up as far as you can. I kind of keep following along, but if you want to try this on your own, that would be great. With that double negative, that makes a positive on the inside of the parenthesis. On the left, we still have y minus 3. When we distribute negative 6/5 in, we get negative 6/5 x minus 6/5. Now to move 3 over, we're going to add. Notice though, we have a fraction and a whole number. What I'm going to do is just give the whole number a common denominator. I'm going to keep negative 6/5 the same, but I'm going to convert 3 to 15/5. That would be equivalent to 3. Then we'd have y equals negative 6/5 x, and then negative 6/5 plus 15/5 is 9/5. Finally, let's sketch the graph for each line to verify that they're perpendicular. The first line, y equals 5/6x plus 4/3, is kind of challenging to sketch. Try your best to approximate that y-intercept and then count up 5 and over 6 in one direction, down 5 and over 6 in the other. Then let's graph the next line. That second line was even pretty challenging to graph. But as you can see on the coordinate system, the blue and the black form a right angle, meaning they're perpendicular. Finally, example 3. Determine whether the two given lines are parallel, perpendicular, or neither. The key for this is we're going to focus on slope. In the first two examples, the first two equations, y equals negative 7 and y equals 3, if we follow the format y equals mx plus b for slope and y-intercept, you'll notice the x term is missing. That means for that first equation, y technically equals 0x minus 7, and in that second equation, y would equal 0x plus 3. Since both slopes are the same, that would make the lines parallel. In that second system of equations, the one equation already has y by itself, making the slope 9. We just need to convert the other one. If we have x minus 4y is equal to negative 3, move x over. We still have negative 4y is equal to negative x minus 3. And then we're going to divide by negative 4. Again, lots of negatives to try to process, so make sure to follow this carefully. Negative x over negative 4 has a double negative, which would make it positive 1/4 x. For the y-intercept, negative 3 over negative 4 is also a double negative, which would become positive 3/4. This slope is 1/4. That means we have a slope of 9 and a slope of 1/4. They're not the same, so that means they're not parallel. And also, the slopes are not opposite signs. Uh-oh, I just moved my screen a little. Sorry. Not opposite signs. Which means they can't be perpendicular. That means these two lines are neither. They would intersect, but they don't form a right angle. That ends topic 0.